Okay, everyone can see it clearly?
Yes, sir.
Yes, sir.
Okay, so let us continue. Um, I think it's better to share the sound also. Okay, and also I guess I have to turn on the computer sound. Why the share sound? Okay, now I guess you'll be able to hear whatever they are saying. Can you hear?
In a metal conductor, the positively charged particles are
Yes,
fixed
sir.
in place, whereas the negatively charged particles, called electrons, are free to move around.
Yes, this is something that we already know, right? Here, the red balls, they represent the protons, the positively charged particle, and the negative.
Sir,
Yes.
we can't see the video.
Is it the case with everyone?
Yes, sir.
Yes, sir.
You can't see the video?
No.
No, sir.
Okay, wait. I'm sharing my screen with you, right? You can see the screen now?
Yes.
So, okay, let me click on the video again. Now, can you see?
No, sir.
No?
No, it's the same.
The same screen you are. কি সমস্যা হলো আবার?
স্যার জুমে এসে শেয়ার স্ক্রিনে ভিডিওটা ক্লিক করেন, এটা শুধু উইন্ডোজ এসে পড়ছে।
জুমের এখানে তো আসলে আমি শুধু এখানে এই যে এটাই দেখতে পাচ্ছি, ডাউনলোড। দেন এটা আসার পরে then I can click on this. Can you see now?
No, sir.
স্যার দেখেন আপনি ফার্স্টে ভিডিওটা অন করেন, ভিডিওটা অন করে শেয়ার স্ক্রিন বন্ধ করে দেখেন ওই জায়গায় ভিডিওটা অন হয়েছে যে ওটা শেয়ার স্ক্রিনে আসবে, শেয়ার স্ক্রিনে চাপ দিলে ওটা আসবে।
আমি সবসময় ওইরকমই করি, কিন্তু আজকে কেন জানি ওটা হচ্ছে না।
নাহলে স্যার আপনি দেখেন এই যে জুম আছে না, জুমে ডবল ক্লিক করলে আপনি যেখানে যাবেন না কেন ওটা দেখা যাবে।
এই যে আমি ভিডিওটা এখন অন করছি, ওকে? ভিডিওটা এখন আমি মিনিমাইজ করে নিচে রাখতেছি। এখন জুমে গিয়ে আমি স্ক্রিন শেয়ার করব, তাই তো?
হ্যাঁ স্যার, জুমে গিয়ে স্ক্রিন শেয়ার করেন, দেখেন ওই জায়গায় ভিডিওটা আসবে।
কিন্তু ভিডিওটা নাই, সবসময় এরকম এসে থাকে, কিন্তু আজকে বুঝতেছি না কই দেখা যাচ্ছে না।
নাহলে স্যার আপনি এই যে দেখেন জুম, জুমে ক্লিক করেন, দেখেন আপনার নিচে জুমে যেটা আছে একদম ফার্স্টে দিয়ে থাকে স্যার, ওই জুমে ক্লিক করেন।
কোথায় ক্লিক করব?
জুমে ক্লিক করলে জুম জুম আপনি দেখেন একটা আছে হচ্ছে জুমের স্ক্রিন শেয়ার করতে হবে, ওটাতে ক্লিক করেন, লাইক একদম ফার্স্টে যেটা থাকবে না ওটাতে ক্লিক করেন আপনি।
মিটিং ইনফরমেশন লেখা এখানে।
ওকে স্যার দাঁড়ান আমি আপনাকে স্ক্রিনশট পাঠাচ্ছি।
ও আচ্ছা, বুঝতে পারছি, দাঁড়াও। ওকে ওকে, আই গেস এখন দেখবা। এখন দেখা যাচ্ছে?
আচ্ছা এই তো।
এভরিওয়ান ক্যান সি?
ইয়েস।
Yes, sir.
ওকে, আমি তখন খালি ডাউনলোডস এর স্ক্রিনটা শেয়ার দিয়ে ফেলছিলাম বলে। ওকে, মাই মিস্টেক। ওকে, এখন শুনো নাকি দেখো? ক্যান ইউ হিয়ার দ্য সাউন্ড অলসো?
In a metal
Yes.
conductor,
Yes, sir.
ওকে ওকে।
the positively charged particles are fixed in place.
Yeah, this is what I was just saying. The positively charged particles that are proton, You can see those are red in color. They are fixed, and the blue colored particles are negative particles. That means they are electrons and they are free to move. Is the meeting recording? Can you see? Is
Yes,
that
sir.
okay? Okay.
Yes, yes.
Okay. So let us continue.
whereas the negatively charged particles, called electrons, are free to move around. A metal typically has an equal amount of positively and negatively charged particles, making the metal as a whole electrically neutral.
This is what we know, right? In normal condition, there is equal number of electron and proton in the in a metal, which makes it electrically neutral because the equal amount of electron balances equal amount of proton. Now, when it is not balanced, when there is some extra electron or there is some extra proton, that time it becomes positively or negatively charged.
If we apply a force trying to push extra electrons into this metal plate, we will not be successful because particles with the same charge repel one another.
You see, this is what happens when if you try to push in extra electron in it. Now, when there will be more electron, they will repel each other and they will force each other out of the metal. Okay, so you have to
If
apply
extra
a force.
electrons accumulate inside the metal plate, they will repel each other and repel any of.
So you see, the force you are giving here is equal to the amount of the force that that you get from the electrons. They will repel each other and they will get them out. Okay, so this force has to be larger now. Okay, then what will happen? The electrons will go again, and as the electrons is going again, this force will also become larger. Okay, then they will go out again. So in order to store charge in a plate, see, this is a single plate, so we cannot actually accumulate charge in a single plate. We need a double plate. Okay, you will see a couple of seconds later there will be another plate that will appear here, and that together is called actually parallel plate capacitor. Okay, you will see two plates, they will be parallel to each other, and when they are together, that time we can store charges in them. Okay, so capacitor is nothing but the battery that we use in our daily life. In that we store the charges, and when we fix the battery in some device, what happens? The device runs using that charge. Like you can consider our mobile battery also. We connect the mobile battery to the electric line, the charger. Okay, what does that charger do? It stores charge in the mobile battery, and when you are using the mobile, the charges flow from the negative end to the positive end, making it neutral again. Okay, when it becomes totally neutral, that time the charge becomes zero and mobile goes off. We have to charge it again, store charge again. Inshallah, you will get to learn or understand.
The new electrons trying to enter. Therefore, even if we apply a force, the metal will remain electrically neutral. Now let us consider a new scenario where there is another metal plate close to the one shown. As electrons accumulate in the first metal plate,
Can you see two metal plates there that are parallel to each other?
Yes.
So now what will happen? Let me tell you in advance so that when it happens, you may understand. Now in the first metal plate that you can see here, some electrons will enter here. So what will happen? As there is more number of electron, they will repel the electron of this second metal plate, and from the second metal plate, the electrons will be going out. So as a result, what will happen? The first metal plate will be negatively charged now because it has some extra electron, and those extra electron has repelled out the electrons from the second plate. So the second plate will have extra proton now. So the second plate will become positively charged, right? One becomes negatively charged, another one becomes positively charged. That's how we form a capacitor.
they will repel the electrons in the second metal plate. The positively charged particles left behind in the second plate will exert an attractive force on the negatively charged particles in the first metal plate. This makes it possible for the first plate to have more negative particles than positive particles. As we add electrons to the first metal plate, an equal number of electrons leave the second metal plate.
Yeah, this is very important to understand. If you push in 5 extra electron here, exactly 5 electron will be moving out. Okay, so the amount of electron that you enter into the first plate is equal to the amount of electron that will leave from the second metal plate.
After a certain number of extra electrons accumulate on the first plate, they will repel any new electrons trying to enter. The first metal plate has developed a net negative charge, and the second metal plate has developed an equal and opposite net positive charge. We can cause this equal and opposite charge on each plate to be larger by applying a larger external force.
You can see the external force has just become larger, right? Then we can enter more electron. And as more electrons are entering, more electrons are getting out from the second plate.
If we remove the external force we are applying, the extra electrons in the first metal plate will continue to repel one another. We have now returned to our original condition where the net charge on each plate is 0. The two metal plates are what we call a capacitor.
This is what I was saying, okay? These two metal plates are called capacitor. And as they are kept parallel, they are generally called parallel plate capacitor.
Note, voltage is shown upside down in this video because the blue arrows will show electron flow.
Okay, let me explain this diagram first so that you can understand what is about to happen and why this is happening. Okay, so at first you can see that this is a parallel plate capacitor. This will be connected with this battery. This is a battery. Okay, so a battery, generally if you take a battery that you fix in your remote or in your wall clock or any of the devices that you use, you will see that in the battery there is a plus end and there is a minus end, right? In one end it is written plus, another end it is written minus. So one is positive, another one is negative end. So let us say you have connected the positive end with this part, with this plate, and the negative end you have connected with this plate. Okay, so what will happen as you have connected the negative plate with this end, negative charges, that means electron will flow through this path and they will come here. So this one has gained some electron, right? Like we saw a little bit ago that we are pushing some extra electron in one of the metal plates. So we will push some extra electron in this metal plate, which will cause some of the electron to go out from the opposite metal plate, the second metal plate. Okay, so some electron will be going out and they will be carried to this end of the battery. Okay, so as a result, you know what will happen, these two will develop a potential difference because one has become positively charged, another one has become negatively charged. So definitely there is some potential difference between them. Now what will happen, we will disconnect it. See, now it is already disconnected, but when we connect it, that time the charge will flow, that I was talking about, that the negative end will give the electron to this metal plate and the positive will give electron to this battery. So this will happen when this is connected. See, the bridge is broken now. But after we have charged it, after we have stored negative charge in this and positive charge in this, then what will happen, this will be disconnected. So then we will connect this path, okay, with the bulb. So what will happen, negative, if this is negatively charged, from the negative charge the electron will flow through it and through the light bulb, and then it will flow and it will come here. So while the electron is flowing from the negative plate to the positive plate, what will happen? The bulb will be lit. Okay, you will see the bulb is lighten up. Okay, so let us see if this is what is happening. Okay, so this is what the direction is a little bit opposite of what I said. I thought this is the negative side and this is the positive. So it is not written here, right? But they have taken this one to be negative, this one to be positive. So from negative, the electron is going. Okay, so this is becoming negatively charged, and as it is gaining some electron, it will repel out some electron from this plate, so the electrons will be coming to this. Okay, so as a result you can see there is a voltage difference. At first they were at the same level, right? But now this one is gaining some electron, the potential of this one will rise higher and higher, you will see. Now we will disconnect with the battery. Yeah, battery disconnect.
By briefly connecting the capacitor to a battery as shown, the two plates have developed equal and opposite charges.
Yeah, you saw that, right? If we enter 5 electron in one plate, 5 electron will go out from the other plate. So one will become 5 plus, another will become 5 minus. So equal and opposite charges.
If we then connect the capacitor across the light bulb, all the extra electrons in the negatively charged plate will move to the positively charged plate through the light bulb.
Now you can see, right? Okay. This plate was negatively charged, so the extra electron will start to flow through this bulb to the positive end of the battery or the capacitor, we can say. Okay, so till the moment it is flowing, okay, this is losing the extra electrons and this is gaining the lost electrons. So what will happen? Slowly they will become neutral, right? Let us say you have some extra electron, you are giving up those electrons, so you are gradually becoming neutral. And if this one has lack of electron, it is now gaining electrons. See, the electrons are entering, so as a result this is also becoming neutral. So when they will become totally neutral, that means you have given up all the electrons that you have, extra electron that you had, or if you have gained the amount of lack of electron that you had, you have gained exactly that amount of electron, then you also have become neutral. So when the plates become neutral, there will be no more electron flow, right? We already saw on that day, when there is potential difference, then there is flow of charge. Remember the similarity between temperature, water level, free surface of liquid, and potential we discussed about. I hope you remember, huh? So if there is no potential difference, then there will be no charge flow. Okay, now there is voltage difference. You can see the green lines, right? Voltage difference. The bottom one is at this level, the higher one is at this level. When this difference will not be there, they both will come in the same level. There will be no charge flow, and you will see the bulb is not light anymore. See, the bulb is lighting. Okay, yellow color. Okay, the bulb has turned off because there is no potential difference between them. So this is what happens actually with our mobile also. We connect with the charger, it charges, and then we disconnect the charge. The connection with the mobile is established, so the mobile is run, and then again, as you are running, the electron is moving from the negative plate to the positive plate, and when they become neutral, the phone dies, the battery dies actually. And you can see the zero amount of charge and the mobile turns off, and you have to connect it with the charger again they will be charged, again you can run the the on this one. Okay,
Voltage of the battery.
okay, আমরা দেখে ফেলছি মনে হয় না?
Amount of charge on the two metals stay on longer. Suppose that we add a special material in between the two plates.
Now this is related to HSC physics. In SSC physics, we just know about this, construction and working principle of capacitor. But what they're talking about now, if you put some other material in between the capacitor, then what will happen? That is something we study in HSC physics. They are dielectric materials. So these are not included in SSC level. In SSC level, they just gave you some idea. Okay, so from the book I thought it will be better comprehensible to you if you see the video and watch that what is actually happening. So did you understand what happened here?
ইয়েস স্যার স্যার
Yes,
আচ্ছা
sir.
একটা কথা ছিল যে আমরা তাহলে ক্যাপাসিটর লাইক যে কোনো জিনিসই ইউজ করতে পারবো ফর স্টোরিং এনার্জি লাইক ফ্রি
Capacitor
এনার্জি
is
বলতে
the
গেলে
thing that you use for storing energy. Then using that capacitor you may run some electrical appliances.
স্যার এই ইয়ার জন্য স্টোরিং এর জন্য তো আমাদের ইলেকট্রিসিটিও তো ইউজ করতে হবে না
Yes, obviously. You have in the battery you have to store the charges first by connecting with some electric source. ওকে, এখন তোমরা তো ভাবতে পারো যে এত স্টোর করার কি দরকার, আমি ডাইরেক্টলি ইলেকট্রিক্যাল লাইনের সাথে কানেকশন দিয়ে যদি কোনো কিছু চালাই অসুবিধা কি? তো তুমি মনে করো ফোন ইউজ করবা, সারাক্ষণ কি চার্জারের সাথে লাগাই বসে থাকি ইউজ করতে পারবা? No, it's better if you can put it on charge and store the charge, and then you can go out and use the phone. So that is the concept of battery, that it does not require you to sit in one place. If you want to use your laptop, you have to stay connected with the electrical line always. No, you can just store the charge in the battery and that battery will support you. Okay, if when you are not connected with the electrical line. Understood the concept?
ইয়েস স্যার
Okay. Now, inshallah, if you're interested, I will forward you one video how you can make this type of capacitor, the parallel plate capacitor sitting at home. Okay. Inshallah, these are easily available in YouTube. Okay. Those who are interested, they may have a look. No problem. It's very easy, I found. Okay. Using two aluminum sheet, you can easily do it. Aluminum foil sheet. Aluminum foil, right? We use it to wrap the papers. Sorry, not the papers, the food. Okay, you see that silver covering around the food sometimes, aluminum foil. Okay, no problem. So a little bit more about that.
Is of the two metal plates.
What just happened? The area got bigger, right? So when the area gets bigger of the metal plate, more amount of charges you can store. This is what they will show you. Okay, a little bit ago when you saw the voltage difference was not much, but now the difference will be very high. You will see, inshallah.
This allows the two plates to develop larger net charges for the same amount of applied voltage.
Yeah, see, the battery is not changed, so the voltage is same, but the difference.
We say that we've increased the capacitance of the capacitor.
Yeah, this is what we say. We have increased the capacitance of the capacitor. That means it can now hold more amount of electron, more amount of charge. Previously, if 5 coulomb charge it could hold, now it can hold 7, 8, 10 coulomb charge, like that, if you increase the area of the capacitor plates of the capacitor. Okay, so we can say that we have increased the capacitance. It are holding capacity এখন আরো বেড়ে গেছে. Now we can run the bulb for.
There is also a third way to increase the capacitance of a capacitor.
Bringing them
This
closer.
is by moving the two metal plates closer together.
The force will be higher. Attraction force between positive and negative metal plate, the force will be higher. See?
Because the two plates are now closer together, they exert greater forces on each other's electrons. This attracts more electrons to the negative plate and repels more electrons from the positive plate, allowing the two plates to develop larger net charges for the same amount of applied voltage. This has the same effect as inserting the special material and as increasing the areas of the metal plates. To create the largest capacitance possible, we want to make the areas of the plates as large as possible, insert the special material in between the plates, and move the two plates as close together as possible. The larger the capacitance, the more energy will be stored for the same amount of voltage. Much more information about electric circuits is available in the other videos on this channel. Please subscribe for notifications when new videos are ready.
Okay, so this is all about the capacitors. Okay, you have got any question?
नो सर सर कैपेसिटर तो বিভিন্ন টাইপের আছে না
Yeah, there are several types of capacitor. This is one type, like the parallel plate capacitors. Okay, those who have joined just now, you may watch the video as I will provide the recording later. Okay, inshallah. So inshallah, next class we will be done with the static electricity chapter. Okay, and then we will solve some creative, and then we will start current electricity chapter. Okay.
Okay.
Yes.
Okay, thank you for joining. Assalamu alaikum wa rahmatullah wa barakatuh.